Advanced construction machinery and heavy lifting equipment drive modern infrastructure, delivering powerful performance, precision control, and reliable operation across demanding industrial projects. The assembly of the CAT 6040 FS begins with the arrival of its major components at the mining site. Shipped separately from manufacturing facilities in Singapore and Germany, the machine's parts are transported on specialized trailers and carefully unloaded using large cranes. Each module is laid out in a planned staging area to prepare for the step-by-step assembly process. The first major step is the assembly of the undercarriage. The massive crawler tracks are installed on both sides, with rollers, frames, and support structures carefully aligned. Workers use cranes and guided tools to position the track frames and secure them in place. This stage forms the foundation of the machine, supporting the weight of the entire structure. Next, the superstructure, which includes the engine house, hydraulic tanks, and operator cabin, is prepared. The complete upper module is lifted by a crane and slowly rotated into position on top of the undercarriage. Precision alignment is crucial to ensure that all mounting points and rotation systems are correctly fitted. The large swing bearing enables the superstructure to rotate 360 degrees once mounted. Following this, the attachment components, the boom, stick, and bucket, are assembled. These parts are pre-assembled on the ground and then hoisted into place. The boom is first connected to the main body using massive pins and hydraulic cylinders. Then, the stick and the bucket are attached in sequence. The tri-power system, unique to the front shovel variant, is also installed during this phase to improve digging efficiency and bucket control. Once all mechanical parts are in place, hydraulic hoses and electrical systems are connected. Multiple pumps, valves, and wiring harnesses are integrated to enable full control of movement and power distribution. After final system checks, the machine enters the testing and commissioning phase. Functional tests include boom lifting, swing operation, and safety feature verification. Once fully tested, the CAT 6040 FS is ready to begin work in the mine. The assembly of the new CAT 6015B hydraulic mining shovel begins with the coordinated arrival of the machine's primary modules at the job site. Each major component, including the undercarriage, the upper frame, the boom, the stick, the bucket, and hydraulic systems, is transported individually due to their considerable size and weight. Once the transport vehicles are positioned, the assembly team conducts a detailed inspection to verify that all modules are free of damage and ready for installation. This initial preparation ensures a smooth and safe workflow throughout the project. The assembly starts with the placement of the undercarriage, which serves as the foundation of the machine. Using two heavy-duty cranes, the team precisely positions the undercarriage onto a level assembly pad. The workers secure the structure with temporary supports and check alignment points to make sure the remainder of the machine will fit accurately. After the undercarriage is stabilized, the track frames and rollers are examined again before the process continues. Next, the upper frame is lifted into place. This is one of the most critical steps because the upper frame houses essential systems, including the operator's cab, hydraulic pumps, main engine compartment, and electronic controls. Due to its large mass, the lift requires synchronized crane operation. The two cranes work in tandem, lifting slowly and maintaining constant communication to avoid twisting or unbalanced load distribution. Once the upper frame is raised high enough, the assembly team carefully guides it onto the slew ring of the undercarriage. Workers then install the retention bolts and torque them to specification, ensuring a secure and stable connection. After the main structures are joined, the team begins installing the hydraulic systems. Large pre-assembled hydraulic lines are routed along the frame, and connection points are cleaned, sealed, and fixed with high-strength fittings. The hydraulic tank, pumps, and distribution manifolds are mounted with the support of one crane, while technicians connect hoses and electrical sensors. Throughout this stage, workers follow strict cleanliness procedures to prevent contamination in the hydraulic circuit, which is essential for the machine's long-term performance. The boom assembly follows as the next major task. The boom arrives in sections that have been pre-fitted with bushings and pin bores. With the help of the cranes, the boom is lifted and positioned at the front of the upper frame. Workers align the boom mounting points precisely so that the large pivot pins can be installed smoothly. Once the pins are driven in and secured with locking plates, the hydraulic cylinders are attached. Each cylinder is lifted individually, aligned with its bracket, and pinned in place while technicians ensure proper hose routing and sensor connections. The process then advances to the installation of the stick. The stick is positioned on the front of the boom using one crane to lift it and another to stabilize the boom structure, preventing unwanted movement. Once aligned, the stick pin is inserted, followed by the attachment of the stick cylinder. After securing all locking mechanisms, the team checks articulation by moving the boom and stick slightly through crane support to verify smooth motion. The bucket installation concludes the assembly of the front attachment. The heavy mining bucket is placed on the ground in front of the stick, and the cranes maneuver the stick downward to align the pinholes. Workers insert the bucket pins and lock them, then attach the bucket cylinder linkage. After hydraulic hoses are connected, the attachment system is tested manually to confirm proper engagement. With all major components assembled, the focus shifts to installing external panels, walkways, ladders, and service platforms. These structures are essential for safe maintenance access and are bolted onto the machine's frame. Electrical harnesses are routed to lighting systems, cameras, sensors, and control units. The assembly team then fills the machine with essential fluids, including engine oil, hydraulic oil, coolant, and fuel. Filters are installed, and the hydraulic system is bled to remove trapped air. Finally, The machine undergoes a series of functional tests. The cranes retract, and the CAT 6015B rests on its own structure. The engine is started for the first time under the supervision of technicians. They check for leaks, monitor pressure levels, and verify the responsiveness of the boom, stick, and bucket. The swing function is tested, and the tracks are engaged at low speed to ensure proper drive operation. Once all systems operate within specification, the assembly is declared complete. Thanks to the coordinated effort of the assembly team and the precise lifting capabilities of the two cranes, the CAT 6015B hydraulic mining shovel is fully assembled, functional, and ready for commissioning in the field. The assembly of the Liebherr LTM 1500-8.1 mobile crane begins with the arrival of the carrier at the designated setup area, where technicians first conduct a complete safety check. This checklist includes verifying structural integrity, hydraulic lines, electronic modules, and all auxiliary components. The team then inspects the crane's dual-engine configuration, the V8 engine positioned in the lower chassis, and the 6-cylinder engine located in the upper works. Both engines are Liebherr's own in-house designs, ensuring optimized power distribution and compatibility with the machine's advanced electronic systems. Next, the electronic LSB bus system is reviewed to confirm that all components are communicating correctly, since this data network coordinates operational and safety functions. Once the preliminary checks are completed, the crew proceeds with the installation of outriggers and base extensions, ensuring the crane has the required stability for further assembly steps. The process continues with the mounting of the counterweight frame. Using an auxiliary crane, the counterweight trays and support structure are lifted into position and secured. This step is followed by attaching the main superlift or luffing system, also lifted and aligned with assistance from a secondary crane. Proper positioning of these elements is essential, as the LTM 1500-8.1 must support loads up to 500 tons with reach configurations of 84 meters, 51 meters with the telescopic boom, or 56 meters with the display jib. After the structural components are fully installed, the team performs functional tests on slewing, telescoping, and hoisting systems. The assembly process concludes with operator training, ensuring the customer's personnel are fully familiar with handling and maintaining this high-capacity Liebherr crane, similar to the other units they operate, ranging from 50 to 750 tons. The installation of the LTM 1500-8.1 Liebherr Korea begins as the delivery truck arrives on site, carrying a wide range of components required to configure the 500-ton mobile crane. Immediately, the crew prepares the working area, ensuring that the ground is level and capable of supporting the crane's weight. Once the truck stops in the designated zone, each part is unloaded in sequence so the assembly team Next, the LTM 1500-8.1 is carefully maneuvered into its exact position. The crane is lowered and aligned on leveled ground to guarantee stability throughout the installation. With the carrier correctly set, the team begins the first stage of assembly by unfolding the outriggers. Each outrigger is extended and supported with pads, creating a wide and stable footprint for the heavy lifting operations that will follow. After stabilizing the machine, attention turns to installing the crane's counterweight system, which is essential for achieving full lifting capacity. The first counterweight plates are lifted from the delivery truck using auxiliary equipment and positioned at the rear of the superstructure. The crew adds plates step by step, gradually building up the stack until the initial 15-ton weight configuration is reached. As the installation progresses, additional counterweight slabs are mounted, bringing the total system weight to approximately 135 tons. This process requires precise alignment of the counterweight frame, locking mechanisms, and lifting points to ensure safe and secure attachment. Once the main counterweight stack is fully arranged, the weight winch system is installed. This winch acts as the essential link between the crane body and the counterweight modules, ensuring synchronized movement and reliable load handling. The team fastens all winch components, checks cable routing, and verifies smooth operation before moving on. The next major step involves connecting the crane top section to the weight assembly. Technicians guide the upper structure into its mounting position, aligning pins, brackets, and hydraulic connections. These joints form the structural bridge between the boom mechanism and the heavy counterweights that stabilize the crane during lifts. The crew performs several checks to confirm correct positioning and mechanical integrity. With the counterweights, winch system, and top connections fully secured, the installation process reaches its final stage. The team conducts a complete inspection, reviewing hydraulic lines, locking pins, fastening points, and safety systems. Once all checks are completed, the crane stands fully configured. All preparations are complete, and the LTM 1500-8.1 Liebherr Korea is now ready for operation. The installation of the LTM 1250-5.1 begins as the carrier arrives at the worksite and positions itself on the prepared ground. The crew selects the most suitable working zone and immediately deploys the VarioBase system, which allows each outrigger to extend to an independent length. By adjusting the support base to the available space, the crane achieves maximum stability while optimizing load capacity, especially in confined areas. Once the outriggers are fully set and leveled, the installation of the upper structure can advance safely. Next, the technicians unload the counterweight slabs from the transport truck. Using the crane's auxiliary hoist, each slab is lifted and secured on the superstructure. The VarioBallast feature enables the counterweight radius to be changed hydraulically, allowing the crane to adapt its ballast configuration to the site conditions. This flexibility ensures high lifting performance, even when operating close to obstacles or within narrow urban environments. After the ballast is assembled, the crew proceeds to prepare the telescopic boom. The LTM 1250-5.1 offers a maximum reach of 96 meters when combined with its telescopic extensions and luffing elements. The boom is raised from its transport position, then the telescopic sections are extended and locked sequentially. Depending on the required reach, additional lattice sections and the folding fly jib may be installed. Finally, all systems, including hydraulics, electronics, and safety controls, are checked. Load moment indicators and operational limits are verified before performing test lifts. Once all parameters are confirmed, the crane is fully erected and ready for operational duty with maximum efficiency and safety. The restoration of the Terex Demag TC 2800-1 begins with the crane's arrival at the specialized paint facility, where the machine is prepared for a complete structural and cosmetic overhaul. Because the TC 2800-1 is a massive lattice boom crawler crane, the process requires meticulous planning and a systematic workflow to ensure each component is refurbished to factory-grade condition. As soon as the crane is unloaded, technicians begin by fully disassembling the machine. Major parts such as the carrier frame, superstructure, outriggers, boom sections, winches, and counterweight slabs are separated and laid out across the workshop to allow independent treatment. Next, the team conducts a detailed inspection to identify corrosion, old coatings, surface damage, and worn areas. Every component is cleaned using industrial-grade degreasers to remove oil, dust, and accumulated grime from years of operation. Once the surfaces are clean, the crane parts move into the blasting chamber. Here, abrasive blasting strips away all old paint layers and rust, exposing the bare metal. This step is essential for achieving perfect paint adhesion and ensuring the new coating system will resist harsh working conditions. After blasting, each component undergoes sanding, smoothing, and surface preparation. Edges, weld seams, and structural profiles are precisely treated to remove imperfections. The parts are then transported to the painting hall, where a multi-stage coating system is applied. First, a high-performance primer is sprayed to protect the steel from corrosion. This primer layer seals the surface and creates a solid base for the subsequent coatings. Once the primer dries, technicians apply intermediate layers designed to increase durability and resistance to UV light, abrasions, and mechanical impacts. The final stage of repainting involves applying the crane's signature finish coat. Using advanced spray technology inside climate-controlled cabins, the painters ensure perfect coverage on both large, flat surfaces and complex geometries such as lattice boom sections. The finish coat not only restores the crane's original appearance, but also provides long-lasting protection for heavy-duty field operations. Small components such as hydraulic pipes, brackets, handrails, panels, and access covers are painted separately to maintain consistent color tone and high surface quality. During this time, stickers, safety markings, and manufacturer graphics are prepared for application once the coatings are fully cured. Simultaneously, technicians clean the operator cabin, repaint the interior frames, and refurbish panels or covers as needed. Window frames, steps, ladders, and walking platforms also receive new coatings to ensure the entire machine looks uniform and renewed. When all components are fully cured, the crane is moved to the assembly zone. Technicians reassemble the superstructure, reinstall hydraulic systems, mount the boom sections, and attach the counterweights. A final inspection checks coating quality, gloss level, safety decals, and overall finish. Through this comprehensive restoration and repainting process, the Terex Demag TC 2800-1 emerges in like-new condition, ready for demanding lifting operations with renewed durability and appearance. The operation of functional toy crane models offers a fascinating look into the world of miniature heavy lifting machinery, capturing the essence of real construction equipment while presenting it through highly detailed and fully operable scale models. Inspired by the assembly sequence shown in the video of the LR1750 crane setup, these toy cranes recreate the same engineering logic, though in a smaller and more approachable form. Their operation demonstrates not only mechanical precision, but also the enthusiasm and craftsmanship of the hobbyists who handle them. To begin with, each toy crane model arrives in separate modular components, just as full-scale crawler cranes do. The lower undercarriage, complete with miniature crawler tracks, is usually the first element to be positioned. Hobbyists place the base frame on a flat working surface, ensuring stability and alignment. Although small in size, the tracks are fully operable and allow the crane to move realistically. The movement is powered either by tiny electric motors or by manual rotation mechanisms built into the model. Once the base is set, the assembly continues with the installation of the central superstructure. This component houses the slewing ring and the primary drive system, enabling the crane to rotate smoothly. In functional toy versions, this rotation is electrically controlled, giving the operator precise control over the crane's movements. The superstructure is locked onto the undercarriage with scaled-down coupling points that mimic the real machine's connection bolts and locking pins. Following the installation of the superstructure, the counterweight system is assembled. Much like the full-sized LR1750, the toy models employ individual counterweight slabs that are stacked or clipped into place on a dedicated frame. Some enthusiasts load these slabs with metal inserts to replicate the actual mass and balance required. This phase is critical because the counterweight stabilizes the crane once the boom is erected. The stacking of the counterweights is often demonstrated carefully, reflecting the same methodical process used with real cranes. The boom assembly is one of the most visually striking parts of the process. The toy crane models feature lattice boom segments that are interconnected using miniature pins or snap-fit brackets. Each piece is engineered to resemble the steel lattice of the real crane, and the sequence of assembly follows the same principles, starting from the base section and gradually extending outward with main boom segments, followed by optional extensions depending on the desired configuration. Operators lay the segments on the ground, align the connecting points, and secure them manually. In high-end models, the boom segments even include functioning sheaves, allowing the hoist lines to run realistically. Once the boom is fully assembled, it is raised into position. In functional models, a winch system powered by small motors pulls the boom upright, while the operator maintains tension on the guy lines. This moment closely resembles the real crane's erection process, where precision and balance are crucial. The miniature boom rises slowly, controlled by the operator through a remote transmitter or wired control unit. As the boom locks into its working angle, the toy crane begins to resemble a full-scale lifting machine, only in a much more accessible format. The next phase involves routing the hoist cables. These toy cranes use scaled-down but functional pulleys and hooks, enabling them to perform realistic lifting operations. The operator threads the cable through the upper sheaves, secures it on the winch drum, and carefully tensions the entire system. Once prepared, the crane can perform various lifting tasks, such as raising small metal weights, containers, or custom-made model loads. Hobbyists often simulate real-world job site activities, creating miniature construction scenes where the crane plays a central role. During operation, the toy crane models demonstrate smooth slewing, adjustable boom angles, and controlled hook movements. The precision of these movements reflects the engineering complexity behind the models. Remote-controlled units allow operators to manage multiple functions simultaneously, mimicking the control logic of actual crane cabs. Ultimately, these functional toy crane models provide more than entertainment. They offer a scaled representation of heavy lifting technology. They allow enthusiasts to study crane mechanics, practice safe lifting principles, and experience the thrill of crane assembly and operation, all within the manageable and engaging world of miniature machinery.